For this lesson in the textbook, I decided to just go ahead and make a scan of the book so that the folks who don't have the textbooks can see what we're talking about. We're getting into things where they're going to need to be able to see. So this should match your textbook that you got from your teacher. I would encourage you to pay attention to the key terms. If I were actually teaching this to a class in person, I would probably have them to go ahead and make flashcards with these terms because they are very important terms. And you will recognize this form of an equation right there. We've already studied that. So we're going to be using some of the terms that we've already used. I am not going to read this word for word. I just want you to have a visual when I'm talking about certain pictures and graphs. But I encourage you to read the examples, read all the things in the margins, but I'm just looking at solving the problems, so I won't be reading this aloud. This talks about, this is page 166 in the textbook, not the homework book, and it talks about using ordered pairs, making a table, finding x and y values. We're going to practice that without reading over all of that. And using slope-intercept form, we've already talked about slope-intercept form, so you're already familiar with that term at least. I do want to call your attention to this core skill right here. So let's take a look at this area. I am going to read this because these margin things are really good in most cases. It says you can learn a lot about an equation by looking at its graph. Learning how to interpret graphs can help you when you graph linear equations. You will be able to quickly recognize whether you have correctly graphed the equation. You can identify whether a line has a positive or negative slope and a positive or negative y-intercept by looking at its position on a graph. The slope of a line can be either positive or negative. A line with a positive slope goes up from left to right. A line with a negative slope goes down from left to right. A line with a positive y-intercept will cross the y-axis above 0, and a line with a negative y-intercept will cross the y-axis below 0. On a blank graph, draw a line with a positive slope and a negative y-intercept, then write the equation of the line. Then draw a line with a negative slope and a positive y-intercept. Write the equation of the line. So we're going to actually do this. I will have to go to a graph sheet. So let me just take a screenshot of that so I don't have to keep flipping back and forth. And let me go back to the notebook where I am doing these problems and see if I have a blank page. I really need a graph sheet. I guess I can just duplicate this one because I think this is worthwhile just to review those terms, get that really fixed in your mind before we tackle some of these other problems. So I'm going to go ahead and make a copy of this graph if it will cooperate with me. It sure did. And then I've lost my screenshot, so I have to go back and get that. My scanner doesn't do double sides, so I'm having to flip back and forth between pages, but I think we'll be okay. So here are the instructions that they want us to do. There are actually 2 tasks here. And let me just highlight those for you. It says on a blank graph, the first thing we're supposed to do is draw a line with a positive slope and a negative y-intercept and write the equation of the line. And then the second thing we're supposed to do is draw another graph with a negative slope and a positive y-intercept and write the equation of the line. So we have 2 different assignments here. All right, so for this orange task, I'm going to go ahead and draw a graph We know we're going to need that. And I am going to do a coordinate plane, not just one quadrant of the coordinate plane. I'm going to go ahead and do this graph. Okay, so it says to draw a line with a positive slope and a negative y-intercept. So if you have a negative y-intercept, it's going to be down below the x-axis. And I'm just going to pick one at random. I'm going to put it right there. No particular reason that I picked that. But we want a positive slope. So that means that our line will be climbing the stairs. So let's just put a positive slope through there. I actually need it to go through the point. This is much harder to do with just one point because there's nothing for it to snap to. Let's try this. There we go. So this is a positive slope. The y-intercept is at 0, -4, and that's what they told us. They wanted a negative y-intercept. If you watched the last unit, we're talking about a baby b. We want the baby b to be negative, but the slope of the line to be positive. And this slope, let's see if we can figure out slope just by eyeballing it. I'm going to just pick up at a point on the graph. Let's just pick up at the intercept. That's as good a place as any. So we rise 2 and we run 1. We rise 2 and we run 1. We rise 2 and we run 1. Rise 2, run 1. Now my line is not exactly spot on there. Let me actually take some of those stairs out. Let's just keep these two. Because my graph, first of all, is not perfectly square, and that's making a difference. But this is close enough that you can see the stair steps in there. That's your slope. That relationship of climbing stairs, that's positive slope. And it is a consistent rise over run. So slope in this case is rise 2, run 1. So slope is positive 2. And we have met the conditions of that first set of instructions. Okay, let's do the second set. And I'm just going to take a copy of that and bring it down here. We've done the orange part, so let's focus on the yellow. And it says to draw a line with a negative slope and a positive y-intercept. So don't get rattled here. The wording is worse than the actual drawing in this case, I think. So there's the coordinate plane. We want a positive y-intercept, which means it has to be above the x-axis. It has to be up in this range. So just pick a point. It doesn't matter. I think I'll put it right here this time. And we want this one to have a negative slope. Now, without another point, I'm not drawing this. I'm just using my laser pointer. It won't be straight. Let me draw it. I could draw it this way with a very steep slope. Try that again. Very steep slope. I could draw it this way with a less steep slope. I could draw it this way with an almost no slope. So with just one point, it's hard to tell where the line should go. But we're not really doing a problem. We're just getting some concepts down. So I'm going to bring this one through about right here because I want to show you something. Now, it's supposed to be negative, so it needs to go down from left to right. It's also very hard. That's pretty good. Okay. So let's label our y-intercept. It's no movement on the x-axis, and we had to climb 1, 2, 3, 4, 5, 6. So again, there's baby B. It's a positive 6 in this scenario. So let's see if we can get some slope figured out here. So I'm going to go from, let me go up first. So we're going to rise 1, run 2, rise 1, run 2. Now, here's where the slope turns negative. I'm going to drop 1. So I'm going to drop down here and run 2. Then I will drop another one after running 2. So you see that those stairs are descending. We are going down the stairs with this negative slope. Okay, so let's calculate our slope just using rise over run. So we rise 1 and we run 2, and we're doing that in a downward direction. So the slope on this one is negative 1/2. Now I want you to compare a slope of 2, which is a pretty sharp increase, to a slope of negative 1/2, which is a pretty mild slope. It's definitely stairs that I could climb. It would take me more energy to climb this set of stairs than it would this set, because the slope is not as pronounced in the bottom one. So think just in terms of common sense. Relate it to a staircase. That's one of the best ways I can tell you to think about slope. Okay, back to our textbook. And I'm actually on page 168. And let's take a look at this example. And again, I'm not going to read all of this. I know there's a lot there. I hope that you will take the time to read it. But let's look at an example. It says to convert a linear equation to slope-intercept form. All right, now you and I have already done this in the last exercise. And remember, in the last unit, I wasn't showing you the textbook. I was working on a page that looks like this. You didn't see the textbook. I was reading that to you. So this book is a little bit more of a challenge because you're actually seeing that complicated text. And I think I'm ahead of myself. Did I skip a page? Oh, I sure did. This is going to be a real problem for me because I have all my evens in one file and all my odds in another. So forgive me. I skipped over. I jumped directly to page 168. So let's backtrack just a little bit and look at page 167. And then we'll get to 168. And I want to look at this example right here. So I'm on page 167. And we're looking at this middle example. It says to find the y value for each x value, plot the points to graph the equation. So the first thing we have to do is look at this table, and we see the x's, and then for y, instead of a y value, I see a formula that I have to work with. So I'm going to copy that formula right here. Y equals negative 4x plus 5. That is slope-intercept form, and I need to plug in some values for x. So I'm going to say when x is 1, y is going to be negative 4 plus 5. Y is positive 1. So when x is 1, y is 1. And I'm just going to put that in the table. Then I'm going to draw myself a a line just to space this, and I'm going to try it again when x is 2. So you just use that same rule that you're working with, and you put in x is 2. So y would be 4 times 2 is 8, and it's negative plus 5. You can also use your calculator right here. If you need it, that's perfectly fine. You will have it on the test, on the HiSET. And then let me do it one more time. I think I'll come right down here where y is negative 4x plus 5, and this time I'm going to substitute a 3. Negative 4 times 3 plus 5, so y is negative 12 plus 5, y is negative 7. So they told us to find the y values. We've done that. And then we need to plot the points to graph the equation. So let me see if by chance, nope. Let me grab a graph. Let me just take this one. Bear with me just a second, because if I try to graph it without a graph, it will not look right. So let's resize this bad boy. I wish I had post-it notes with these graphs on it where I could just stick it wherever I needed it to be. Okay, so what are we actually graphing? We're going to be graphing these points right there. So I do need a full coordinate plane. I can't get by with just a single quadrant. Probably for all of these, it's best to just draw a full plane, because then you know you have what you need. The first point is 1, 1, both positive. So I'm going to go over 1 and up 1. That'll be right there. Then over 2 and down 3. Right there. Over 3 and down 7. Now, if this doesn't make sense, I would encourage you to speak to your instructor, because this is important that you get this pretty well nailed down. Okay. So this is a line with a very, very steep slope, and it is traveling in the negative direction. So let me try to, that's too thick, sorry. Bear with me, please. Let's bring him right down through here and let it snap to. So there is the line that we drew based on our points. And again, those points are in that table. We have 1, 1, 2, negative 3, 3, negative 7. So we did what it said to do. We found the y values, and we graphed it. Now I'm going to extend that just a hair. I want you to think through this with me. Let's see if we can find our slope just using rise over run. And in this case, the rise is actually falling. It's going downhill. It's down the stairs. So the rise is going to be negative because it's going down each time. Now, the question is, how much is it going down each time? Well, it's going over 1, which we'll need in just a second, and then it's going down 4. And that's still too thick, isn't it? So it's moving over 1 and it's dropping 4. And then it moves over 1 and it drops 4. So the rise, the fall, I really should say, the change in that vertical distance is 4. So it's negative 4. And then the run, it's just moving over 1 each time. So the slope is a negative 4. That's a very steep slope. Those stairs are something that I would not want to have to climb down. They're very, very steep because the slope is not very close to zero. The higher that slope gets, the steeper the stairs will be, regardless of positive or negative. So that was just a good little exercise, and we've done what they wanted us to do. Okay, let's take a look up here at this core skill. Solving a linear equation. An integral part of algebra and problem solving involves solving linear equations. To graph a linear equation, you will often have to solve first for y. To solve a linear equation, isolate the variable on one side of the equation. To do this, perform the same operation on both sides of the equation. Now, a lot of students will panic reading that because it sounds so horrific. But let's actually solve it, and you'll see that you already know how to do this. So it says to solve -2, and I'm going to put it just here in this white space, -2x minus 8 equals 4. And they want us to solve it for x. So all you have to do is draw your frame. They want you to find x on one side, and then everything that's not an x will go on the other side. So I have that -8 that needs to move. So let's add 8 to both sides. And that leaves me with -2x equals 12. And then divide by -2. So x is -6. That is called solving an equation. Okay, I'm not going to talk about this calculator because we do not use a Texas Instruments calculator. We use a Casio. So I'll skip over that part, and then I need to go to page 168. Here we are, back where we started. This is the one that I did with the orange and yellow highlighter, where we did let me pull that back up here. Right there. We did that one already. So let me go back here. I'm on page 168. I'm looking at the example 1. And it says to convert a linear equation to slope-intercept form. Now, I'm going to skip over their explanation. It's great, but we already know how to do this. The equation we're working with is 5x plus 6y equals 12. That's in standard form. They want us to convert it to slope-intercept form. So the way that I taught you to do that, again, their explanation's great, but let's use what we know. Remember, we said we put our pattern down on top. That's what we want. Slope-intercept is y equals mx plus b. So then you start matching up what you have. Well, we have a y and a y. Okay. We have a constant over here, the 12. We can leave that there. But we need to get that 5x over to the other side. So I'm going to subtract it here, which will make it cancel away. And then over here, I'm just going to bring it in there. So we have our mx, sloping x, it's right there. And then there's baby b. But we still have this thing. Okay? So we're going to have to deal with that 6 somehow. Sorry, I don't want to do that. Okay, the first thing I'm going to do is go ahead and write it in the proper form. So we have the y term equals mx plus b. So that all that I have left is that 6. So we're going to divide it from this side, and we're going to divide it from this term and this term, so that it will cancel here, and we're left with y. Slope is negative 5/6 x, and 6 into 12 is 2. And that is the equation in slope-intercept form. Now remember, in the last unit we talked about it's the same equation, it's just wearing a different outfit. That first one they gave us up here, this was in standard form. We converted it to slope-intercept form. This is exactly what we were doing in the last chapter, last lesson. But this is a little more complicated because of that fraction. That looks a little funny. I never liked converting standard to slope-intercept. I struggled with that a little bit. But fortunately, we don't need standard very often. So here is the final answer for this example. Okay, that's all on that page, so let's go to page 169. 169. And it goes through a pretty lengthy description of how to graph an equation. Let's just jump on down here to the think about math question. Oh boy, this looks like fun, doesn't it? It's okay, we can do it, because you've built the brick wall. You have done what you needed to do to build the brick wall. Answer the following questions. Taxi fare with green taxis is $2 plus 50 cents per mile. The equation to represent total taxi fare is right here. We don't have to find it. They gave it to us. We just have to figure out which line on the graph matches the equation. So let's take the equation and think about it just a minute. We have a positive slope. Let's just study this a second. Ignore all that other stuff. Where is the slope? Well, it's right here. And it's a half. 0.5 is the same as 1/2. So the slope is positive. And it's also not very steep. This is a gentle slope. If this were a mountain, it would be more of a hill. It's just a gentle slope. We also know, because this is slope-intercept, we know baby B. We know where it crosses the y-axis. And what this means is that it will cross y at, remember, x would be nothing, and 2 is the positive 2 that we're getting right there. So let's look for something. I'm going to start with baby B. That's the easiest one. So y, my gosh, this is complicated. Y of 2 is going to be right here. Okay, so we have eliminated a whole lot just by this one. It could be line B that runs up this way, or it could be, this looks like line D that runs this way. Now I'm liking D because it's a gentle slope. It's not a very steep slope at all. B is a pretty steep slope. Let's figure out exactly, though, what the slope is. And I'm not going to use the formula. I'm going to use common sense. B up here runs 1 for every 1 it drops or climbs. It's over 1, up 1 is what I'm trying to say. So it will run 1 for every 1 down. All right, you've got it if you think about it right here. This is a slope of 1 over 1. So the slope of B, the B slope is 1. Actually, I wrote that the wrong way. Sorry. The slope of line B is 1 over 1, which is 1. All right, let's look at D here. I like D. D is going to be the only other option. I'm not even going to go there. It has to be B or D because that's what intersects at point 2. So it's going to have to be D. And D is the one I like anyway. It's a very gentle slope. It is positive, and it crosses at positive 2. So the answer to this one is line D. What is the total fare for a 5-mile trip with green taxis? Well, if we're going to let this be our formula, that's all we need to go to. When y is 0.5x, we're going to substitute 5 for x. This is 5 miles right here, plus that $2. So y is going to be 2.5. That's when you multiply this one. Use your calculator if you need it. Plus 2. So the fare, that's what this y represents, the dollars, is $4.50. Okay, so to answer number 2, we just write in $4.50. And I think I'm going to stop this video. It's getting just a little bit long, and when we come back, we'll tackle this one up here.